similar to one from 8.1. It's called the quotient of powers. Quotient of powers. Okay, and the quotient of powers says that when you divide with same basis, what do you do with the exponents?
Subtract.
You subtract. Okay? So it says that when we divide with same basis, we're going to subtract. Subtract the exponents. Miss T, can you see this? This marker is terrible.
Yeah,
I
I
think
can
it's time
hardly-
to
I
let this
can
one
hardly
go
see.
away.
Isn't that well?
Horrible.
Wasn't it? Alright, we'll see if this one works. Okay, so guys, this one says that if we have a to the, there we go, a to the m divided by a to the nth, do they have same bases?
Yes.
So therefore, what do we do with the exponents?
Subtract.
Subtract, which you guys did very, very well as we checked our homework today. M minus n, okay? So that's our quotient of powers. Our quotient of powers says that if we divide with same basis, we subtract the exponents, okay? So for example, okay, we'll just do a couple examples here again because I think this makes a lot of sense to you. All right, if we do 3 to the 5th divided by 3 to the 3rd, we're going to take and subtract 5 and 3. And what is 5 minus 3? 3 to the 2nd. And keep your answer with exponents. They want you to keep the answers with positive exponents. Good, let's do another one. Another one would be negative 8 to the 9th divided by negative 8, just negative 8. What is that negative 8 really raised to?
The first.
Of the first power. So put a 1 here. So what would our answer be, guys?
8 to the
Negative.
Negative 8 in parentheses because it's a negative base to the what?
8.
8. Very good. Okay? Raise your hand if that makes sense so far. Okay, good. Okay? All right, a couple more. Okay? Let's do one more like that. Okay? 2 to the 11th divided by 2 to the 6th. What does that become? 2 to the 11th divided by 2 to the 6th. 2 to the what, class?
5th.
2 to the 5th. Good. All right. So we understand the quotient of powers. Again, the quotient of powers just tells you to subtract the exponents when you have same bases and you're dividing. Okay, the next one, the next big exponential property with dealing with quotients is called the power of a quotient. Power of a quotient. And now in 8.1, we had power of a what?
Product.
Product, right. So now we have power of a quotient, which means that when we divide, when we have a fraction inside the inside the parentheses, we have to raise everything inside of that to the power outside of it. So this says that we have a divided by b to the m power, means that I have to raise the numerator to the power outside and the denominator to the power outside. Okay, and that's what power of a quotient says. Like we have to raise the numerator and denominator to the power outside. Outside the parentheses. That's really what it's saying in terms of, kind of in layman's terms, in terms of what are we saying. It means that we're going to raise everything inside that parentheses, numerator and the denominator, to the power outside of it. Okay? All right, let's go ahead and do a couple examples of this. Okay? 3/2 to the 4th power. 3/2 to the 4th power. So guys, if we have to use this power of a quotient, what do we do? When we first raise to the 4th power?
3 to the 4th.
3 to the what, class?
4th.
4th over
2 to the 4th.
2 to the 4th. Now I believe they want us to keep it as exponents first, but if I asked you to simplify this further, what would it become? 3 to the 4th is what? 3 times 3 is 9, 9 times 3 is 27, 27 times 3 is 81, and then 2 to the 4th. 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. So if they ask you to do it again, make sure you pay attention to what we're asking you to do. Are they asking you to leave it as exponents? Then you will leave it as 3 to the 4th over 2 to the 4th. If they ask you to simplify the expression, then you will write it as 81 over 16. Jack?
Do I need to take these notes, because I've got the note-taking guide notes and the old ones that we took, like last trimester, so can I like take these notes again?
Well, what I said before is just, if there's anything that you feel that you need to add and make sure that you still clarify, that's what I want you to make sure you add in your notes. No, I want your notes to be out that you had before, and add anything to that, anything that you didn't understand. Because I know some people said it helped them to just add to what they've already had in their notes. So, all right, so that's a good question. All right, next one. And I just want to make sure that you're paying attention, you're answering the questions as we ask them, because obviously that's what we do. All right, -2/5, guys, to the 5th power. What do we do for this one? Where does the negative always go in terms of the numerator or the denominator?
Numerator.
The numerator, right. So then how are we going to write this? Negative what?
-2.
-2, but what does -2 need to be in? Parentheses, very good. To what power? To the 5th over what? 5 to the 5th. Let's go ahead and simplify this, just as we did the previous example. What's -2 in parentheses, and that's why it's very key to put the negative in parentheses, to the 5th power. Obviously it's to an odd power, that means it's going to stay negative. So -32 over 5 to the 5th.
3,125.
Very good. 3,125. Good. Yep. Okay. Does it make sense to how to do that? Okay. I have a couple other ones that's going to combine the quotient of powers and the product of powers. So I want to do a couple of those before we move on. So I want you guys to put this in your notes or add them to your notes. Let's do one like this. X to the 11th times 1 over x to the 6th. You got a couple of these on your worksheet we did last night. What should we make sure we put x to the 11th over? What number should we put x to the 11th over to make it a fraction?
1.
Over 1. So now we are combining two properties. One we learned in 8.1 and one we learned in 8.2, which means we're combining product of powers and quotient of powers. So we're going to divide this by 1, and now doesn't that mean we're just going to multiply across? Okay, what do we get on the top? X to the 11th. What do we get on the bottom? X to the 6th. Now, if we're dividing by the same basis, what do we do with the exponents?
Subtract.
Subtract, so x to the what, class?
5th.
X to the 5th, and that is our final answer.
Alright.
All right, let's do one more of those, and we'll see if that makes sense. You guys help, try this one on your own here, see if you can do this one. How about, actually this is another good one. 6 to the 7th times 6 to the 4th divided by 6 to the 6th. We didn't do one like this. I'm going to do one like this, and I'll do another one like the previous one. So we'll do one more example after that. What do we need to do first? What do we need to do first in that last example? You need to add the exponents first, don't we? We need to simplify the numerator, and then we remember, we always make sure we understand that fractions are like grouping symbols. We always simplify the numerator, simplify the denominator, and then lastly divide. So in this case, we're going to want to add the exponents first. We're not going to divide these two exponents or subtract these. We're going to add the exponents first and simplify the numerator. So 6 to the what, class?
11.
11 divided by 6 to the 6. So we're going to add first. Now what do? Now we subtract the exponents. So simplify the numerator, simplify the denominator, and then lastly divide, which means in this case we're going to subtract the exponents, which is 6 to the 5th. Very good. Last one we're going to do here, we'll move on to our next section. All right, how about this one? 1 over 9 to the 5th times 9 to the 11th. Now on this one, what do we need to do? On this one, what do we need to do?
Put 9 over 1.
Good. Make 9 to the 11th over
1.
1. Now we multiply across. And what do we get for the numerator? 9 to the 11th. Obviously, anything times 1 is itself. And then what's on the bottom?
9 to the 5th.
9 to the 5th. Now, because we're dividing with the same basis, what do we do with the exponents?
Subtract.
So 9 to the what, class?
6.
6. Very good. Okay. Do these make sense?
Yes.
We're really going to make sure we understand this whole process when we start implementing, putting two properties together into one problem that you were asking to simplify, not just using one property, as we did in these examples, but now getting into 2 and 3 properties that we're using in one example. All right, now let's go ahead and move on to the last part of 8.2, which is, like I said, combining now like 3 different properties into one. We'll do a couple of those, then we'll move right on to 8.3.